Good afternoon, and thank you for joining our drop-in demo series. I'm Gary McAuliffe, and I lead the sales team here at Pureport. I've got Johnson Coughlin, our VP of Solution Engineering, with me as well. And Johnson will be conducting the demo portion of today's webinar. Hopefully, you've gotten through your children's online learning session and your second or third dog walk of the day and are ready to talk a little multi-cloud. We developed this series as an opportunity for you to engage with Pureport in a very low-pressure way to allow you to investigate our platform and understand how it enables the interconnection of cloud networks. In today's topic, multi-cloud networking, how to privately connect AWS to Azure, we'll show you how easily the Pureport multi-cloud fabric allows customers to move from a multiple cloud architecture into a true multi-cloud architecture. We'll spend the majority of our time today in the demo portion, but I wanted to give you a little bit of background and context before Johnson walks you through the demo itself. So why don't we get started? I think it's evident that the era of multi-cloud is truly upon us. In Flexera's 2020 State of the Cloud report, it said that 93% of enterprises, large enterprises, are now leveraging a multi-cloud strategy. It's a really staggering number, but I'm not sure it tells the whole story. We believe that a lot of those organizations are leveraging what I would describe as a multiple cloud strategy, but not yet a multi-cloud strategy. So what do I mean by that? Well, we believe some enterprises probably have things like Microsoft Office running in the Azure cloud, but may have applications running in AWS. Or maybe they're leveraging multiple clouds due to some reliance on SaaS applications that might exist in different clouds. They're not necessarily or really truly moving data between applications in different public clouds. They're more of a siloed approach, if you will. We believe, however, that 2020 is really going to be the year that starts to change. And while it's driven by a number of factors, we think of three big ones. First, Kubernetes. The impact of containers and container management platforms on IT applications, we believe, will drive significant multi-cloud adoption just due to the pure portability of the components themselves. Likely, your company is already engaged in a process with Kubernetes or some container approach. And we really do believe that this will drive a desire for operating in multiple clouds. Another one we see a lot is licensing. We believe that the impact of some software licensing agreements will also cause multi-cloud adoption. And an example would be a customer that has a database that they need to run in, say, the Oracle Cloud or in Azure Cloud, but are running applications maybe in AWS or Google. We see that happening already a good bit, and I think it'll continue in 2020 to really drive it. And then the third is obviously our friend COVID-19. We believe that the implications from the pandemic will cause enterprises to connect their clouds and move data in between clouds and workloads on a much regular basis. Some of this will be for the purpose of HA or disaster recovery, maybe the need to support mobile workers, and a number of other elements. But even if you just look at the earnings reports of the cloud providers in the last month or so, cloud adoption is dramatically on the rise, and we believe that multi-cloud networks and multi-cloud adoption will be part of that. To achieve, though, this benefit of multi-cloud architectures, one thing is really going to have to change, which is multi-cloud networking. To date, there's been kind of three major issues when you start to talk about multi-cloud networking. In other words, connecting two or more public clouds directly together. Complexity, high cost, and performance. Until now, stitching clouds together has been an extremely complicated solution requiring significant lead times, manual configurations, and really deep networking knowledge. In a world where most of our other IT functions have become very simple, fast, virtual, cloud networking still remains cumbersome, slow, and complicated, almost very non-cloud-like, if you will. And today there's been kind of three ways in which people have built multi-cloud networks. Companies can land gear in like a cloud on-ramp data center and use that gear to route between clouds. They can go to their carrier and maybe provision a private circuit to their data center, or maybe add cloud connections as nodes on their MPLS network, or they have the opportunity to connect the clouds using just the internet via a VPN between two clouds. Each of these has significant cost implications, And like, for instance, on the co-location side, can be pretty expensive, and particularly expensive in some of these cloud on-ramp data centers. So the data centers that are really close to the cloud, the pricing can be quite expensive. Plus, you have to pay for your gear. You're obviously paying for power, connections to each of the cloud providers, and it can be, once you get started, it can be a relatively expensive process. Carriers, while also relatively expensive, are also looking for long-term commitments. So not only is it a challenge on the cost side of the equation, but it also has an impact to the agility that you would like to connect. So you may be committed or locked into a 3-year contract if you spin up a connection to one or more clouds. And the VPNs seem relatively straightforward, but they can actually have huge cost implications. And I'll tell you why. Each of the public cloud providers charge for data that flows out of the cloud. They call it egress bandwidth charges. And if you're moving data back and forth between two clouds, you pay basically an extremely significant egress bandwidth toll, which can be as much as 9 cents per gigabyte in both directions. Fortunately, the cloud providers have all created an alternative solution allowing for discounted egress bandwidth charges that go across their private connectivity options like AWS Direct Connect or Azure ExpressRoute. If you focus on the right-hand side of this chart, you'll notice that by leveraging private connectivity options, and in this case, we're talking about AWS and Azure for the purpose of our demo today. But if you were doing that, a customer that's consistently moving 1 gigabit per second of traffic between two clouds or between those two clouds could save thousands, if not bordering on tens of thousands of dollars a month in egress bandwidth charges reductions by leveraging private connectivity options like what Pureport helps enable versus doing an IPsec VPN. The other issue that you see, significant issue in multi-cloud networks, can be a performance. And particularly if you're leveraging, say, a carrier solution that has you connecting your clouds through your corporate data center. If you leverage that kind of traditional hub and spoke model where the hub is your corporate data center and you're connecting multiple clouds together, and that data has to flow all the way back through your corporate data center between the two clouds, your performance can really be crushed. We were working with one customer that was experiencing 10 to 15 milliseconds of latency between their data center and one public cloud, which in and of itself wasn't horrible. But when they added the second public cloud and all of that data had to traverse all the way back to the data center, hairpinning back to the other cloud, the latency that was caused was almost double and really started to have an impact on user experience. So what's the solution? Well, obviously it's move routing closer to the cloud. And as we discussed, this can be accomplished by moving your gear to one of these cloud on-ramp data centers. But as we also discussed, that can be quite expensive. And this is really where the Pureport multi-cloud fabric can start to really have some significant benefits. So as I said, we call our solution the multi-cloud fabric. And our goal is to seamlessly orchestrate connectivity between the cloud providers, allowing us to spin up connectivity in days, really in minutes versus days or weeks. Next slide, please. Our solution is a fully layer 3 platform, and it speaks to the clouds in the networking protocol that they require, so BGP. And we've built our solution to be fully programmable on a modern API architecture, on a software stack that leverages general purpose compute in these key cloud on-ramp locations. So, i.e., we're extremely close to the cloud. We're not built on big routing or big iron routing gear, but virtualized routing services built in software containers. You might think of it as a extremely cloud-like architecture. What we've done is we've tried to solve the challenges of multi-cloud networking. We've made them less complicated, and we'll let the demo speak for itself on that case, but you'll see just how easily we've made the ability to connect two clouds together. We've reduced the cost. Obviously, we've already put gear in these on-ramp data centers, and we can virtualize those connections for a number of customers in a way that causes the customer not to have to go put that gear there. Plus, by leveraging the private connectivity options of the cloud providers, we can help our customers save between 50 and 70% of their egress bandwidth charges as part of that solution. And finally, from a performance perspective, because we're sitting close to the cloud and because we can literally in some cloud regions do 1 to 2 milliseconds of round trip latency between two clouds, we can drive extreme performance and not have our customers suffering from the hairpinning of 20 and 30 and 40 milliseconds of round trip latency as they have to take the long trip down to their data center before circling back to the next cloud. So let's get into the actual specifics of the platform itself, and let's talk a little bit about, we'll actually show it to you. So what I want to do is turn it over to Jonathan and let him walk you through us connecting two clouds between AWS and Azure, and give you a chance to see the platform live and in action. Jonathan, you want to take it over?
Yeah, thanks, Gary, and thanks again to everyone for joining us today. Before I jump into the actual demo, I wanted to take a quick minute or so to walk through what I'm about to build, and also take an opportunity just to explain the platform architecture at a super high level. So what I'll start with is two cloud environments that I've already built out in AWS and Azure. And from there, I'll use the Pureport Multicloud fabric to connect the two using AWS Direct Connect and Azure ExpressRoute for private connectivity, really with Pureport as the layer 2 connection broker in between. So in the center of this diagram, you see a representation of our highly available engines. And as I think Gary mentioned, we're very cloud-like in that these are built on general purpose compute. In other words, on physical servers that we maintain in each of our core locations, with specialized network cards for enhanced performance. Each of those locations also has switches and other management components, but these highly available engines are really the heart of the customer-specific layer 3 routing aspect of our platform. So when I add my first cloud connection, essentially what happens is that we deployed two virtual routers, these containerized routers, to terminate BGP peering for that cloud, along with a pair of HA route reflectors, which are used to create a layer 3 full mesh network with all the additional clouds and customer locations that we connect. All of these routing instances are dedicated to this customer account. Again, they're deployed on disparate hardware across discrete network paths for full high availability. And they're built out in such a way that they're fully segregated from any other customer, any other account, and even from any other networks that you might have built in your own account. So really, privacy, security, performance, and scalability are all built into the platform from the ground up. So as we connect additional clouds or customer sites, each new HA connection includes an additional pair of HA virtual routers, which are joined to the network in a full mesh. And what this means is that as you add more connections, the performance and throughput of your network scales horizontally automatically without you needing to revisit the architecture or design. It also means that as I add the third, the fourth, the fifth, the 10th, cloud or customer location to my network, I only have to connect each of them one time versus manually creating a full mesh, which, at 10 connections, that's 45 individual links I'd have to configure. And so as you'll see in the demo, we'll go ahead and establish private connectivity between our AWS and Azure environments. Again, without having to order a circuit, without having to configure a router, without me even having to come up with the IP addresses and BGP passwords and other network primitives that are needed to complete that peering. Our platform does all that for you. But most importantly, without having to wait the 30 or 90 days, associated typically with buying network, kind of the old-fashioned way. So let's go ahead and jump into the demo. And as I switch over to my browser, you'll see that this is our Pureport customer self-service console. So this is a graphical interface that our customers can use to interact with our platform. However, I always like to mention that we are API first. What that means is new features are added to the API, then they're built into the console. The console actually makes API calls on the back end. There's no end run around the API or anything like that. And we also expose that API for our customers to be able to use directly. You can see we've got our API reference published right here in the console for customers to be able to use, and even to be able to try out different commands if you want to. And we also have published integrations with Terraform and Ansible for those customers that are using those tools for automation and orchestration. One other thing I'll mention real quickly is that as I run through this demo, I am going to be jumping between the Pureport console, the AWS console, and the Azure portal to show show the audience what's happening in each of those. I'm also going to need to grab some values out of each of those consoles, and then at the end of the day, that will be where the BGP peering is finalized. So I'm going to start by creating a new empty network. And what you'll see come up on my screen is a map showing our 5 core locations. These are the locations where we physically map to the cloud on-ramps, and if you're familiar with where the cloud regions and on-ramps are, these will look just like the usual suspects to you. In addition to those 5, we have about 150 where we can take a physical private port. That's outside of the scope of today's demo, but just be aware that these are the 5 locations where we map to those on-ramp locations in the continental U.S. So let's go ahead and add my first connection. We're going to make that AWS Direct Connect. I'm going to choose the Chicago location. I'm going to map that to AWS US East 2 there in Ohio. I'm going to choose private peering. And we will do a 50 meg connection at HA. You'll notice we do have a non-HA offering for AWS and a few other connection types, something that one of our developer customers asked us for. Next, I'll need my AWS account ID, which I'll grab real quickly out of the AWS console. So copy that to the clipboard, plug that guy in. You'll see, by the way, that I could click next, go through all the BGP settings, turn all the knobs, plug in my networks, turn on NAT, configure that, give it a custom name. Again, I'm not going to do that for the purposes of the demo. I'm going to let the platform do what it does best, and that is to generate all that information for me and make my life easy. So jumping back over to the AWS console, you can see that those 2 new connections are populated here out of Chicago. As the customer, you'll see I didn't put in my full credentials, just my account ID. So I have to go in and accept each of these 2 circuits. That lets AWS know that, yeah, I actually did tell Pureport to order these on my behalf, and goes ahead and gets started with the provisioning of those 2 circuits. Now, typically this takes anywhere between 30 seconds when I'm not doing a demo and 4 to 5 minutes when I'm actually trying to show somebody how the platform works. So while those connections are going through the acceptance process and getting built out, I'm going to go ahead and jump back in to the Pureport console and build out my next connection, which will be a connection to my Azure environment. So again, I'm going to choose Azure as a type. We'll choose the Chicago location. We'll choose the North Central US, which is the Illinois region of Azure. Again, we'll choose private peering and a 50 meg speed for that connection. Next thing I'm going to need is an Azure ExpressRoute service key. So this is an alphanumeric string that's generated when I build my ExpressRoute circuit in the Azure console. And you can see that circuit is sitting waiting, not provisioned. We're going to go ahead and paste that in. Again, I could go through, set my IP addresses, set all the other network primitives. I'm going to let the platform do all of that work for me. And at this point, again, we're reaching out via API with that service key, passing that to Microsoft, validating it, making sure that I've chosen the same locations on both sides, making sure that all the other setup on the ExpressRoute side of that connection is done properly, and that circuit's valid and waiting to be provisioned. Typically with ExpressRoute, this takes 30 to 45 seconds. Once that's complete, we'll see this provider status flip over to provisioned. And from there, we'll come in and provision our private peering. By the way, you'll see that I've already got IP addresses set there. That's actually from a previous session that I went through with this circuit. Typically, I would need to copy and paste those IP addresses, which are going to be provided back on the Pureport console, along with the autonomous system number and the VLAN ID, and then finally the BGP peering password. In this case, since those are already set from a previous session, I should only need to plug in that password. There we can see it's flipped over to provisioned. So we'll open up that private peering, quickly jump back over to the Pureport console, want to validate that those IP addresses are the same, 8 and 12, and they are. And then I'm going to grab my shared key or BGP peering password. I'm going to plug that guy in. And we'll click Save. That's going to take 30 or 45 seconds for that to complete. And once that's done, BGP peering should come up within just a few minutes. You'll see, by the way, that it's gone ahead and deployed those two redundant routing gateways on our engines. And you can see BGP peering has actually come up on that first connection already and should be up on that second one within just a few moments. Once that's all done, we'll start to see routes populate from the Azure side. In the meantime, let's jump back over to the AWS side. Looks like the primary connection has been accepted and is available. So while we're waiting for the secondary, I'm going to go ahead and finish building out my virtual interface. In order to do that, I'm going to need my Direct Connect Gateway ID, which we give you a deep link to a list of your Direct Connect gateways. Copy and paste it. And then we give you deep links into the AWS console to automatically fill out all those network primitives and other values necessary. You can see here we filled out the IP addresses, the BGP authentication key, and we'll click Create Virtual Interface. And we'll see that virtual interface created successfully. Let's check and see if that second circuit has been accepted yet. Looks like it may be another minute or two for that secondary circuit to come up. But the idea is once that's done, we'll go through the same process for the second virtual interface. And at that point, then those VIFs will be built out. You can see the primary one that I built here is building out and in pending status. Again, typically 4 to 5 minutes for that to complete and BGP peering to come up between Pureport and AWS. And so in the meantime, while that's all processing on the AWS side, why don't we check and see if we've had any questions come in via the chat. Gary, I don't know if you mentioned that at the beginning, but if anybody does have any questions, please feel free to type them into the chat if you haven't already.
Yeah, let's give it a minute. I'm glad I forgot to do that earlier, so thank you. Let's give everyone a minute.
Okay. And in the meantime, it looks like our secondary circuit is up. And we'll go ahead and create the virtual interface for that guy. And accept the command.
It does look like I have a question, but I'll let you finish that, and then we'll hop over to the question.
Okay. And you can see now, by the way, that the primary VIF has been created and is down. That secondary one that I just created is still pending. And typically within again just a few minutes, we'll see both of those come online. You can see BGP peering, by the way, just came up on that primary. We can see on that particular gateway, he's seeing the route from Azure. He's seeing the route also learned from his local peer, which is the AWS connection. So at this point, even while we wait for that secondary connection to come up on the AWS side, I've got full connectivity between my AWS environment and my Azure environment, again, over fully private networking. So secure, highly performant, and built without having to talk to a telecom sales rep. So, Gary, what did you say? We already had a question.
Yeah, we do. So the question is, what if I need to connect clouds in different regions? So what if, for instance, AWS in US East and Azure in US West? How would we go about that?
So there are really, in that particular example, there are really 3 ways that I can think of off the top of my head to do that. Pureport does provide a nationwide backbone. Actually, if I click the little compass arrow, you can see we've got an HA backbone between each of those locations. However, there are a couple other ways to go about it, and you might even want to combine multiple approaches. But so if if you had as an example an AWS environment there in Ohio, and your Azure environment were out in Seattle, you could create the Pureport network and the Pureport connections actually in Seattle, connect to your AWS Direct Connect gateway out there on the West Coast, and then ride the AWS backbone from the Oregon region, which is where the on-ramp out of Seattle connects to, back over to Ohio. Conversely, you could build it as we've built it here, but with the ExpressRoute circuit configured to use the Chicago on-ramp but connect to your Azure environment out in Seattle. And so either one of those methods, you're actually using the cloud provider's backbone, and they do not charge any additional transfer fee above and beyond what what you pay for Direct Connect or ExpressRoute to make that happen, really within the geopolitical region of North America. So those are kind of the three ways.
Yeah, thanks, Johnson. And thanks everyone. Looks like hope everyone had helped give a good view of what Pureport is up to and kind of where we're headed. I don't know if you've go back to the slides, Johnson, but we've got more of these sessions, actually trying to do one every week as we continue to go through our at-home strategy. So this week, next week, we're going to do hybrid connectivity to the cloud, which will actually show connecting sites. We're going to do a DevOps focused one on the 28th, and then we will show Google and Google Cloud Interconnect on June 4th. So look for more invitations or come out to our website to register for those other additional drop-in demo series that we have coming. We appreciate your time today and wish you the absolute best. Please hope you and your family stay safe, and we look forward to connecting with you again very soon. Thanks.